which now leads me to another thing. Anybody interested in boating? Anybody interested in cruises? Anybody been on a cruise? Yes? Okay, so there, what?
I've piloted a boat.
Okay, so what do cruise liners look like?
They're big.
They're big.
They're tall.
And they're tall.
And they're long.
And they're long.
And wide.
And they're wide.
And they kind of go like that.
They kind of go like that. All of those things. So because things are in water, on Earth, we talk about center of gravity. We talk about center of mass. What's the difference between center of gravity and center of mass? Yes. They're exactly the same.
Oh, never mind.
No, that is a good point. It is easily confused. Center of mass is your center regardless of wherever you are in the universe. Center of gravity is the same thing as long as you're on planet Earth. That's the difference. Make sense? However, if you are outside planet Earth, center of gravity makes no sense, right? It has to be the center of mass. Okay, so now center of mass is for something that I put on the table. There is another term that gets introduced if you put things in water. It's called the center of buoyancy. Okay, so what is the difference between center of mass, center of gravity, and center of buoyancy? So if you have a ship, it generally looks like this.
We're looking head on.
Yeah, we're looking head on onto the ship. When the ship is not in water, the water level is here. When you do, okay, this is going to sound terrible. When you do put the ship in water, the water level rises. Again, think of a small pool and a big boat. You put it in, the water level rises. We are not talking about the ocean. Okay, so it makes sense, right? So this makes sense right now. This ship has a center of mass, regardless of where you put it, right? You put it on land, you put it in the ocean, you put it in your swimming pool, you put it anywhere. It will have a center of mass because everything that exists has a center of mass, right? But when you put it in water, it additionally has what is called the center of buoyancy, which changes depending on the boat and how much it rotates due to weather conditions. In general, the center of mass and center of buoyancy will coincide with each other. They will be on the same plane. Not necessarily one-to-one correlation because there will be off, right? Because the water gets displaced. So in general, let's see if this is my center of mass. Center of mass is where mg acts. Let me call this G. Center of gravity, center of mass, whatever you might want to call it. Center of buoyancy, if the boat is completely straight, will be, oh, this is not a straight line. Hold on, make sure that this is a straight line. So I need to make a point. Okay. When this boat is completely straight, your center of buoyancy, B? Sure. Okay. Is in line with your center of mass. Now, what happens when this boat tilts? Say due to wind conditions or, I don't know, waves. Will its center of gravity change? No. The center of mass, the center of gravity will not change. It will remain exactly where it is. However, what happens to its center of buoyancy?
It changes from the ship's perspective, but its still suits.
It has to, yes, it changes from the point of view. If you were standing here, it will change. So like, oh wow, we are a big person standing on a small boat. If you were standing on the boat, you will see this center of buoyancy change. So it will go to a new B prime. Now we have to define a new thing, which they call M. And that M is defined as metacenter. That's a very ship naval definition. And metacenter is the point at which an imaginary line, vertical line, passes through the G and B when the ship is completely vertical and stable. So this is what it gets defined as. You standing here will see M, G, and B completely straight. Again, recognize this is not drawn to scale. This is actually not this far away. Technically, if I was to do this properly, this M would be somewhere here, very, very close to G. So this distance between G and M is very important for ships. This determines the stability of the ship. So when people construct cruise ships, this height becomes very, very important because that determines how much the ship can roll without causing the passengers to throw up. But it cannot be that stiff that so there is a fine line between every ship where it can not roll too much and also not be too stiff. Because if it is too stiff, you will feel every single wave. Whereas if it's too loose, then you will just be like swaying in the wind. So that height becomes very important. That height, if it is above the center of gravity, we call it positive and stable equilibrium. If it falls below remember, the buoyancy center changes and the metacenter changes, but center of gravity does not change. It stays the same. It depends on the boat. It could be negative. This height could be negative. That means the equilibrium is stable and the ship is likely to flop. Or it could be 0 when it's exactly at M, and that way there is neutral stability.